Professional installers. I'm Tim and I'm with Topper, and this is the pro startup for the evaluation of the WOW water on water reverse osmosis system. You'll notice over here at a kitchen sink we've installed a nifty little diverter valve here, color coded with a red feed line and a black waste line that will be dripping into the sink here. And we're going to have a dry startup here. The system has been pulled from the box. The cartridges were inserted into their positions, post, RO, and pre. The system is now ready to install and have our lines attached. We're going to show you how to remove the dust covers, which, Gary, if you can bring it in here, we're going to, with our little spanner wrench here, we're going to apply pressure to the collet and pull the black dust cover from the F port, which is the regulator. We're going to pull the FA2 dust cover and the drain line. We're also, for the sake of this installation and demonstration, we're going to pull the PW pin and we're going to pull the SQ pin over here. Okay? So what we've done here is we have set up a little test rig here that we're going to install and insert the yellow line into the SQ side, and the blue line is going to go to the FA2. So we have two outlets right here related to both of those channels. We're also going to install a gauge on the PW side. Notice we have a green tube here. Okay, so that's what we've got. Then we're going to install the red line, which is our feed, and we're going to insert that. We have an emergency shutoff valve here. We're going to take the black waste line and insert it into the D port. So basically, we are set and ready to go. All of our little parts over there. We have a TDS meter here that we're going to be looking at the TDS. All right, so the system is dry. We are all connected. I'm going to turn on the system. Make sure we have water pressure here. I hear water rushing in through the system. Emergency shutoff valve is in the open position. Everything seems to be nice and tight and leak-free. We're going to open up the blue line here, which is the FA port simulating the faucet. We're going to open it up. We're going to hear a shot of air coming from that. We have a combination of air and a little bit of water coming out of there, mostly air. This is the bladder. On the inside of the storage tank is collapsing in its normal state. It is full of air. And right now we're collapsing the bladder with water rushing through the pre-filter, through the membrane, and going in and around the storage bladder and squeezing the air out of the storage bladder. And when that bladder completely collapses, then water will be diverted from that area, that channel, and start populating the post filter. And as it fills up in the post filter, eventually it will start coming from the blue line here in a little drool or start off with a few drips. But what we're going to do is we're going to evacuate a little bit of the air that is on the outside of the bladder. And when I wait till I hear water stop rushing into the unit, we're going to open up the SQ line, which is the yellow line right here, and we're going to get a shot of air out of here. Yeah, we got air. I'm going to let that evacuate out. This is purging the system. We'll close it. And open it up again. More water is going to be purging from this. Under the current conditions, we're operating at about 60 psi right now, And the water temperature is sufficient for an ample flow. We should be flowing at approximately 2 gallons per hour here from the membrane. And one more time. This is purging the air on the outside of the bladder. Got a solid stream of water. We'll turn that off. Waiting a few more minutes. Now what we're doing here, once again, is we're purging the air out of the system. And we didn't pre-fill the cartridges. You don't have to do that, provided that you have this kind of a setup. We're just kind of expediting the test. And let's see one more time. Solid stream of water. Any minute we'll see water starting to drip out of the blue line here, or our simulated faucet. There we go. Less and less air. Once we have water dripping from the faucet, then we'll adjust our waistline here, which is the outside of, there we go. We've got our water. This is the RO water that is being produced by the membrane. It's also rolling through the post filter. And at this point, we are flushing the membrane. Any of the preservative that may still be on the surface of the membrane is now being flushed off, and the TDS that is in the post filter is being flushed away. But just if I don't open up the SQ line, then I'm going to over concentrate the membrane and it's going to shut the membrane off. So what we're going to do is we're going to open up the SQ line here, which is the concentrate side of the membrane, and I'm going to match the flow. And I'm just throttling the SQ line back to a decent flow to where they're almost matched even. There we go, we're evenly matched. Okay, so what we're going to do is we're going to let this roll down the drain or into our sink here, this is a closed loop system. It's dropping into a tank, and you heard the pump there a second ago. It's repressurizing. You can do this on your test bench, or you can do this on your kitchen sink. It doesn't matter if you have a nice little attachment off the tip of the faucet like this. We're going to let this go for about an hour, and that way we'll do a TDS check to see if everything's flushed away. It may take a little bit longer than that, but we're going to see what our rejection rate is after an hour. Now, don't worry about how much water you're wasting. It's not that much. Right now, we're flowing at about 2 gallons per hour here, and we've adjusted our concentrate size through the SQ port to the equal amount of water, about 2 gallons per hour. So we'll see you in an hour. It's been an hour. We're back, and we're going to check our TDS off the tip of our simulated faucet right here. And we're going to dump the first amount of water out of our little sample cup. There we go. Let's turn it on. We have a measurement of 8 parts per million. Okay, let's check our feed, which is right off the tip of the faucet here. Let's take a reading of that. 132. So we're in the mid to high 90s in terms of rejection rate. And that's just, we've allowed water to fill across and flow across and flush away the preservative off the membrane, and we flushed away the carbon fines that would be registering TDS, and so we've flushed the system. So now let's turn the faucet off. We shut down all the lines. We should start registering pressure on our product water channel right here, which is the PW port. This pressure is building up on the inside of the storage bladder, pressure is being produced by the membrane. It's going in and against the bladder, and it's starting to pressurize the post-filter area, which comes up and shifts the control valve. Once it hits at about 40 psi, the needle will take a slight dip, and that's the signal that it's about to open up the waistline, and the waistline here at the tip of the faucet will open up. The gauge will drop to 0. We go into high-speed production, and the water has a free pathway to the inside of the bladder, and this is where we have the enhanced performance once it drops to 0. Where are we? It's a slow mover and a little cooler today. So as it drops up, maybe pan out, Gary, and put it on the tip of the faucet here. And that faucet is about to open up here. There it is. We are now at 0 back pressure here on the membrane. We're in high-speed production. Now, knowing that there's no pressure here on the product water channel, I know that I don't have any pressure on the outside of the bladder as well, because they're basically one and the same. It gives me an easy way to eliminate or to remove my startup rig here. So what I'm going to do is I'm going to take my little spanner wrench here, or fitting removal unit, take the gauge off, take my plug, and reapply it to the PW port. I'm going to do the same thing with my SQ. Make sure that you do not hit the faucet or open up the faucet, or both the squeeze and the PW would pressurize and you'd have water going all over the place. So here we're basically have established the unit for filling. You can leave the gauge on if you want and witness the gauge pressurizing as the bladder fills up and it reaches the inside perimeter of the tank. The pressure gauge will register pressure on the PW side just before shutdown, and it should be at almost line pressure at that point. Okay, so at this point, we have removed our rig. The blue line here can be attached to the faucet. Just plug it right into the faucet underneath the kitchen counter by removing the shutoff valve here, and then just plug it in. So this system is essentially ready to go. I'm just going to run a real quick test here, and got a little bit of flow here. My waistline should open right back up again. I'm going to walk away from this machine in about 45 minutes under my current operating conditions. This machine should be completely full and shut down, witnessed by no flow coming out of the tip of this faucet. Then I know that I have a full tank, and at that point the system would be ready to detach, put on the shelf for tomorrow's installation. Okay, that's it. Water on water, wow technology, here you go. Thanks.